Hello everyone, welcome to Equal To, and this is the 10th episode of the second chapter in class 9 science, which is matter around us pure. So if you haven't seen the past 9 videos yet, go and check them out before watching this one, and if you have, we can move on to the video. So in this video we are going to see a few things continuing on with separation. So in the previous video as well we saw what kinds of separation can be done to separate individual components from a mixture, and continuing with that we are going to see a few separation techniques in this video as well. Okay, the first one is how can we separate different gases from air. As we know, air itself is a mixture of few gases, and the gases that are present in air are oxygen, nitrogen and some argon. So air is a mixture and it's a homogeneous mixture. Now we have to separate the individual gases from the air. So you have to extract oxygen from it, you have to extract nitrogen from it and argon from it. So how do we do that? That is what we are going to see now. So as we know, air is a homogeneous mixture, and this separation can be done using something called fractional distillation, and this is what we have seen in the previous video. We ended the last video with fractional distillation. So please, if you haven't seen the last video yet, I'm giving you a link, please go and check it out first. So fractional distillation is what you're going to use to separate individual components of air. So what exactly happens? So we have air and we are going to compress and cool the air. Okay, we have the air that is available, abundant in nature, and we are going to take it and compress and cool. Compress in the sense you are going to increase the pressure, and by cool they mean decreasing the temperature, obviously. So when we do this, when we increase pressure and decrease temperature simultaneously, any gas for that matter liquefies. So it becomes liquid. From gaseous state it converts back to liquid. So we know liquid on heating becomes gas, and or decreasing pressure it will become gas, right? So if we do the reverse for gas, it will become a liquid. See, these are things that we seen in first chapter as well. So by increasing pressure and decreasing temperature, we convert air into liquid air. Now after converting it into liquid air, you are going to warm this liquid up. So when you are warming this up, it again becomes gas, and since this is a mixture, it has different gases in it, and all these gases have different boiling points. So these gases evaporate and become liquids at different temperatures, and that is how we can separate these gases from air. Okay, now in this table we are given that oxygen's boiling point is minus 183 Kelvin. Okay, and argon's is minus 186 and nitrogen's is minus 196. Sorry, it's degrees Celsius, not Kelvin. That was my bad. Okay, so oxygen is minus 183 degrees Celsius, argon is minus 186 and nitrogen is minus 196. These are the boiling points. Okay, and oxygen is present 20.9% in the air. The composition, the ratio that is it is present in is oxygen is in 20.9%, argon is in 0.9%, nitrogen is in 78.1% of air. Okay, so this is it. Now to arrange these gases in the increasing boiling point, we know that minus 196 is the lowest one, argon is minus 186 and oxygen is minus 183, so that has the highest boiling point. So when you heat the liquid air, nitrogen is the one that is easier to attain, so that is the one that gets converted into air first. So that gets converted into gas. When heating the liquid air, nitrogen gets converted into air first, it goes out, and then argon, and then finally we are left with the liquid which is just oxygen. So you can extract oxygen from it. And also when these come out as gases, you can condense them and convert it back into liquid, or you can just store them as gas. So that is up to you. Now which of these gas forms liquid first when cooled? So that is something that we saw just now. Okay, now moving on, this is the apparatus that we use to separate the individual gases from air. So what you're going to do is that you're going to let in air, and under high pressure and lower temperature you're converting it into liquid. So in the second part you're converting it into liquid. So first you're just applying pressure on it, and then the hot air it goes in, and you are letting it pass through freezing cold water. So it's getting cooled and it gets compressed. so it becomes liquid. Now when it converts into liquid, you are then letting it into a separator, and in the separator it just the carbon dioxide comes out as dry ice, because carbon dioxide doesn't convert into liquid. We know this, we have seen this already. Carbon dioxide is sublimable, so it's what we call as dry ice. It directly becomes into gas, and directly on cooling and increasing pressure, it directly becomes into solid. It doesn't come to the liquid phase at all. So dry ice comes out, and the rest of the liquid air is led through expansion jet, and then here it is warmed up. Here the liquid air is warmed up, and at different temperatures different gases come out of it, and you are just and at some point the other gases will have reached their boiling point. They would have evaporated, they would have converted into gas and were let out, and only oxygen will be left, because that has the highest boiling point, right? So that will be left out, so you can collect it as liquid oxygen. So in this way we are going to separate it. Now moving on, we come to the next separation method, which is called crystallization. So we'll see this with an activity. So we have to separate we have to extract pure copper sulphate from an impure sample. So what you're going to do is that you're going to take that impure sample of copper sulphate, you're going to put it in a cyanide dish, you're going to add a little amount of water, just enough for it to make it a saturated solution. Okay, so just enough for it to dissolve. So you are going to make that solution, and what you are going to do is that you are going to filter it. You are going to filter it to remove any impurities that is present there, and then you are going to heat it. Now you are not going to boil it, you are just going to heat it for a while and let some vapors out, and then you are going to cover it with filter paper. Okay, so when you cover it with filter paper and let it for a while, what happens is called crystallization. So it forms as crystals. The liquid copper sulphate, we have heated it for some time, and we have closed it with a filter paper, and this forms as copper sulphate crystals, and these crystals are said to be pure in nature. Okay, so any impurities that don't crystallize, only copper sulphate crystallizes, and we would have also separated impurities using filtration. Okay, so this is what we call as crystallization. So crystallization is a process that separates pure solid in the form of crystals from a solution. So that is what we call as crystallization. So generally we use this to purify solids. Copper sulphate, when you started, it was a solid, and at the end also it was a solid. You are just going to purify it. Okay, now crystallization technique is better than evaporation. Why? So on heating, some compounds, some materials, some solids, they decompose. Like sugar, if you just heat sugar, not the sugar syrup that you create, in that you would also add water. Now if you heat just the plain sugar, it would get charred. So what is charred? Charred is like, it's a black colored thing. Like if you heat sugar, it will become charred, it will become black, it will decompose, it will no longer be sugar. This is because of the dryness. Okay, so this doesn't happen with crystallization, because you are going to add water and then heat it and then let it crystallize. So dryness doesn't happen. Heating, we are not heating it directly, so decomposition doesn't happen. So that is an advantage for crystallization. And also some impurities, even after filtration, they are there in the solution. So now these impurities, they still remain even after doing evaporation, because that doesn't help. But when crystallization, only copper sulphate, or only the thing that you are trying to make it pure, is going to crystallize, not the other things else. So that is also another way it gets pure. So this contamination doesn't happen in evaporation. So that is why crystallization is better than evaporation. Now a few applications of crystallization are extracting salt from seawater. So that is an application of crystallization, and like not just extracting in the sense you are just going to evaporate, and after doing that you are going to do crystallization to purify the salt. And also separation of crystals of alum from impure samples. So alum is something like you would have seen older days, after shaving they would use a stone like thing on their face. So that is alum. It's disinfectant. It basically prevents septic. Okay, so that is alum. Now we have aftershave lotions, but basically that is alum. So extracting alum from impure samples can also be done through crystallization. Now those are the separations method. Now we finally come to something called water purification system. So we have water in our dams, and how that reaches to our home, they go through this process to purify it. So they take water from the reservoir and they keep it in sedimentation tank for a while. So when keeping it in sedimentation tank, some impurities, some particles that float, they settle down. Okay, now those impurities settle down. Now moving on, we are going to move it to loading tank. In loading tank, suspended impurities also settle down. The ones that haven't settled down in the sedimentation tank will also settle down. Now moving on, we then move it to filtration tank, where we have layers of fine sand, gravel and coarse gravel. So what are these? These are going to just filter your water. So fine sand is going to take a lot of impurities, and then gravel, and then so when water passes through all these layers and get collected from the bottom, the filtration has happened. A lot of impurities would have been removed, and then finally you're just going to add chlorination. You're going to do chlorination, which is just adding chlorine salt into it, so that kills bacteria, and then it is finally sent to your homes. So this is an important question. This might be asked, so you have to you might be asked to draw this diagram and explain it. And also the diagram that we already saw, this one, where we are going to separate the different gases from liquid, that also is an important diagram. So just learn it, and you might be asked in your exams. So I think that is all for this video. I hope you understood these things. If you have any questions, please put them in the comments, and if you haven't seen the previous videos yet, go and check them out. Thank you so much for watching. See you in the next one. Bye for now.